Hi, this is Wendy Lightheart. In this video, we're going to be learning about radical expressions and functions. So first, some definitions. If a is a positive real number, then this symbol here, this notation, represents the positive or principal square root of a. It is the positive number we square to get a. If we put a negative sign in front of this notation here, this represents the negative square root of a. It is the opposite of the principal square root of a. One way to think of it is we could rewrite negative square root of a as negative 1 times positive square root of a. This is really a good way to think of it when you're trying to simplify these expressions. Then our third definition, the number or variable expression under a radical symbol is called the radicand. Together, the radical symbol and radicand are called a radical, and an algebraic expression containing a radical is called a radical expression. So here's a picture here. We have the square root of 81 is how we would read that. And the square root symbol here looks like a check mark with a line extending over the 81. That's the radical symbol. And 81 itself is called the radicand because that's the number that's under the radical symbol. And then all together, the symbol together with the radicand, the square root of 81, is called a radical. So let's evaluate some radical expressions here, some square root expressions. So for a, recall that if you have a negative sign in front of a square root, a good way to think of that is it's the same as negative 1 times the positive square root. So what is the square root of 16? That would be 4, because 4 is the number that I would have to square to get 16. So if you think of that as negative 1 times 4, you would get negative 4. So that's our answer. Now for B, notice that there's subtraction in the radicand. If you ever have addition or subtraction under the radicand, then you must simplify that expression underneath the square root symbol. So perform that addition or subtraction, and then you can perform the square root that's indicated by the square root symbol. But you must do that addition or subtraction first if it's in the radicand itself. So we would have to perform the subtraction, 36 minus 121, and that would give us negative 85. So then this is the square root of negative 85, which is asking for the positive number that you can square to get negative 85. Well, you could think about it for a long time, but you're never going to find a real number, positive or negative, that you could square to get negative 85. And so since there is no real number that can be squared to get negative 85, this expression turns out to be not a real number. You can never take the square root of a negative number. Just keep that in mind. Then for part C, notice that the subtraction is not in the radicand. It's actually between two separate square root expressions. So in that case, you would actually perform the square roots first and then do the subtraction between those results. So if we take the square root of 36, we get 6, and the square root of 121, we get 11. And then we perform the subtraction, 6 minus 11, and we get negative 5 as our answer. So if the subtraction is in the radicand, addition or subtraction, you must do that first and then take the square root. But if the subtraction or addition is outside of the radicals, separating two separate radicals, then you actually perform the square roots first and then the addition or subtraction. Now for this next example, we're going to look at a radical function, in this case a square root function. And we're going to evaluate this particular function f for the values 4 and -1. So remember, when you're evaluating a function for a given value of x, what that means is you're going to replace the x with that value and then simplify that expression. So f of 4 would be equal to what we get when we replace x with 4. So we would have negative square root of 4 squared plus 9. Then we have to simplify that expression to find out what f of 4 is equal to. Notice there's addition in the radicand, so we have to perform the addition before we can take the square root. Of course, we can't add 4 squared and 9 until we actually square the 4, so we also have to follow the order of operations in the radicand. So we square the 4, we get 16, and we add 9 to that, and we get 25. So now we have the square root of 25, and then don't forget about that negative sign in front of there. And remember, you can think of that as -1 times the square root of 25. And since the square root of 25 is equal to 5, we end up with -5 as our answer. Now let's plug in -1 into our function. So to do that, we substitute -1 in place of x in our function. So that's going to look like negative square root of -1 squared plus 9. So again, we have to square the -1 and add the 9 before we can actually perform the square root. And when you square -1, you get +1. You add 9 to that, you get 10. So we have negative square root of 10. Of course, 10 is not a perfect square. There's not a whole number that you could square to get 10. So if you punched it in your calculator, the square root of 10, and round to 2 decimal places, you will get 3.16. And then of course we have that negative sign in front of the square root symbol, so that makes this approximately -3.16. Okay, now let's talk about the domain. We're going to look at the domain of a square root function. And so first let's review what domain is. The domain of a function f is the set of all real numbers x for which the value of f of x is defined. So in other words, it's the collection of all numbers that you could plug into the function and simplify it to a real number. So for a square root, remember that only positive numbers and 0 actually have real number square roots. Because remember, if you take the square root of a negative number, that's not equal to a real number. So since that's the case, the domain of a square root function is the set of real numbers for which the radicand is greater than or equal to 0, since those are the only type of numbers that will give us a real number square root. So to find the domain of a square root function, we set the radicand greater than or equal to 0, and then we solve the resulting inequality, and that will give us our domain. So let's find the domain of this function. F of x equals the square root of 6x minus 18. So the domain will be any x's we could plug into this function and get a real number as a result. Well, remember that the only values of x that will give us a result in this case, since this is square root, would be any x's that would make the radicand either positive or 0, or in other words, greater than or equal to 0. So we start by setting the radicand greater than or equal to 0, and then we solve that inequality. So we would add 18 to both sides, and then divide by 6 to get our solution here, which is x must be greater than or equal to 3. So that's our description of our domain. So the domain is, the domain of this particular function f is in set builder notation. We would read this as all x's such that x is greater than or equal to 3. Or in interval notation, we would write that as a square bracket with 3 being our smallest number in our domain, and then comma, all the way up to infinity, and then close it with a parenthesis. Okay? Now let's look at simplifying radical expressions. So if a represents any real number, so a could be a number, or it could be just a variable, or it could be some expression that represents a real number. In any of those cases, if we take the square root of a squared, then that is equal to the absolute value of a. So we use this rule whenever we're simplifying the expressions, the square root of some expression being squared. So in our next example, we're going to assume that x is any real number and then simplify these 3 examples. So for the first one, the square root of 49x squared, we want to use this rule up here in the box. So what we need to do is figure out what the a is. So really the question that we're needing to answer is what is being squared to get 49x squared? Or what can I square to get the expression 49x squared? Well, I would need a 7 to get the 49. I would have to square 7 to get 49. And I just need to square an x to get the x squared. So the expression that I would need to square to get 49x squared is 7x. So now this is written in the form that we need to use our rule, where the 7x is like our a. Can you see that? So then what is our answer? Well, it's going to be the absolute value of our a. Since a is 7x in this case, the answer is the absolute value of 7x. Now you might be wondering, why do we need the absolute value signs? Well, remember that when you take the square root of a number, that's asking for the positive number that can be squared to get the radicand. Well, if I had 7x without the absolute value signs here, and x happened to be a negative number, then 7 times x would be a negative number, so I'd get a negative answer, which is not possible. Because remember, the square root symbol is asking for the positive number that can be squared to get the radicand. So we just insert the absolute value signs there to make sure that the expression will always be positive no matter what x is. Now if you were told at the beginning that x is going to be positive, then you wouldn't have to worry about those absolute value symbols. But in this case, x could be any real number, which includes the negative numbers. Okay, let's look at our second example. So we want to know what is being squared to get the radicand, which is x squared minus 6x plus 9. We're trying to figure out what our a is, so we can use the rule up here in the box. Well, for this one, it's a trinomial, so we would factor it. And if you factor that expression, you should get x minus 3 times x minus 3, which is x minus 3 times itself, so we could rewrite that as x minus 3 squared. So the answer to that question is x minus 3 is the expression that we would have to square to get the trinomial x squared minus 6x plus 9. So x minus 3 is our a in this case. So this would simplify to the absolute value of x minus 3. Okay, for our last example on this one, we need to ask ourselves, what is being squared to get 100x to the 12th? Well, we'd have to square 10 to get the 100, and we'd have to square an x to the 6th to get x to the 12th. So put those together and that gives us our a. We would have to square the expression 10x to the 6th to get 100x to the 12th. And you could verify that by using your rules of exponents. So a is 10x to the 6th in this case. So using the rule, this would simplify to the absolute value of 10x to the 6th. However, in this case, if we raise any real number to an even exponent, it will always be positive. So 10x to the 6 will always be positive no matter what value x is. So whenever that's the case, we can drop the absolute value signs. And so in this case, we get 10x to the 6th as our answer. Okay. Now for another definition. The real number b is a cube root of the real number a if b cubed is equal to a. So this notation here represents the cube root of a. So it looks very similar to a square root symbol, but there's that little 3 there that indicates that it's not a square root, it's a cube root. So if b cubed is equal to a, then b is the cube root of a, so we'd write that as the cube root of a is equal to b. And then the number or variable expression under the radical symbol is called the radicand. So just like with the square roots, with cube roots and really any number root that we'll be looking at, the number or expression underneath that radical symbol is called the radicand. And the number 3 in this notation, that little number 3, is called the index, or sometimes called the root number. With a square root, the index is 2, but you'll never see the 2 actually written in. It's just implied to be a 2. So keep that in mind. And then together, the radical symbol and the radicand are called the radical, and an algebraic expression containing radical is called a radical expression. So again, the index here in this picture down here, this index of 3, that's the index, and then 8 underneath the radical symbol is the radicand, and the entire expression together is called the radical. Okay, so now we have another rule, this time for simplifying the cube root of a cubed. Notice with this example we do not have absolute value signs around the a. And this is because when you cube a negative number, you get a negative number. When you cube a positive number, you get a positive number. So we could get a positive result, or we could get a negative result when you take the cube root of a number. And so we don't need to have absolute value signs to ensure that we get a positive, like we did with the square root. So let's look at a couple examples. We're going to first find the cube root of negative 8x cubed. We're going to simplify that. So we're asking ourselves, what is being cubed to get negative 8x cubed? Well, in order to get a negative, we'd have to cube a negative number. Because remember, a negative number to an odd exponent will always be negative. So we would need a negative 2 to get the negative 8, because negative 2 cubed would be equal to negative 8. And then we simply need to cube an x to get x cubed. So the expression that we need here is negative 2x. That's the expression that would have to be cubed to get negative 8x cubed. So that is our a. So what does this simplify to? It simplifies to the a, which in this case is negative 2x. Now this next one is a little bit more difficult, but I think you could still handle it. What is being cubed to get 5 minus x to the 6th? Okay, so if this was just x to the 6th, what would your answer be? Well, we'd have to cube x squared to get x to the 6th. So instead of x to the 6th, we have 5 minus x to the 6th. So the expression we need here is 5 minus x in parentheses squared. And again, if you apply your rules of exponents here, you can see that we would have to multiply 2 times 3 to get 6, so these are indeed equivalent to each other. But now it's written in the form that we can see the a. The a is in the red here, 5 minus x squared. So when we simplify this, it simplifies to what that a is. So this simplifies to 5 minus x in parentheses squared. Okay, so one last concept here. This is a more general rule that has to do with any n, whether n is even or odd. And the indices, the index numbers are always going to be integers. So 2 on up, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So if n is even, when you simplify the nth root of a to the nth, so if the index matches the exponent there, the answer is the absolute value of a. And if n is odd, then the nth root of a to the n is equal to just a. So let's look at a couple examples. So again, we're assuming x is any real number, and we want to simplify these expressions using our general rules up here. So for a, notice that the index is 5, which is odd. So we just have to figure out what our a is, and that will be our answer. So what would we have to raise to the 5th power to get 32x to the 15th? Well, 2 to the 5th power is 32. And to get x to the 15th, if we divide the 15 by the 5, that will tell you what the exponent is that we need on the x. So that would give us x cubed. So our a here is 2x cubed. That's what we'd have to raise to the 5th power to get the original radicand here. And since that's our a, that is our answer. Okay, so our last example, we want to know what to the 6th power is negative 4x in parentheses to the 6th. Well, this one's a little easier. It's just looking right at us here. Negative 4x is being raised to the 6th, so that's the expression that we'd have to raise to the 6th to get that expression. So all I really did here was just rewrite the negative 4x in red, because that is our a. And since this is even, the 6 is an even number, we have to make sure we put absolute value signs around that a for our answer. All right, that's it for today. Have fun simplifying these radicals.